Okay, Longhorns, this is the fifth 6 weeks test 1 review for analytic trigonometry. And so we're going to start with problem 1. I'm going to draw a triangle representing our problem situation, and then we will find the area. Okay, so we have a triangle with sides 22, 15, and an included angle of 48 degrees. We're going to use the area formula, 1/2 of side A times side B times the sine of C. So 1/2 times 22 times 15 times the sine of 48 gives us 122.62 meters squared. So on the test, you're going to be required not only to draw a picture of your triangle, but to show what formula you used and the answer in units squared, whatever the units are. In the next problem, we're using the law of sines to solve a triangle. The triangle's already drawn for you, so all you have to do is use the law of sines, and you only have to find side C. So the first thing you're going to want to do is label your triangle. Okay, so across from angle A, we have side A. Across from angle B, we have side B. And across from angle C, we have side C. So to set up the law of sines, we're going to use our ratios. So we could use side A, which is 18 feet. Let me erase that. 18 feet divided by the sine of A, which is a sine of 102 degrees, equals side C over sine of C, but we don't know what C is. So to find C, we're going to need to add the other two angles together and subtract from 180. So now we know that angle C is 45 degrees. And we can cross multiply, put this in our calculator, and we get that C equals 13 units. In this case, our units are feet. So C equals 13 feet. So we cross multiplied. We did 18 times the sine of 45 degrees divided by the sine of 102 degrees, and we got 13 feet. And number 3, we're using Heron's formula, and Heron's formula has two parts. The first part is A plus B plus C divided by 2. That gives us this value S, and then we're going to plug S into our formula. S times S minus A times S minus B times S minus C. All right, so 12 plus 9 plus 5 divided by 2 gives us 13. We plug that into our calculator as the square root of 13 times 13 minus 12 times 13 minus 9 times 13 minus 5. And we get an area of 20.39 meters squared. Don't forget to put your unit squared at the end of your answer. Okay, in number 5, we're using the sum or difference formula to rewrite the expression. All we're going to do is rewrite tangent of 165 degrees using our sum and difference formulas. So I chose angles 120 plus 45. Those two angles together add up to 165 degrees. So if I do this formula, 120 degrees plus 45 degrees, that would be a sum formula. So I'm going to use the sum formula on my math chart to write this in. So I'm using tangent of 120 plus tangent of 45 divided by 1 minus tangent of 120 times tangent of 45. And that's all you have to do to rewrite You're just plugging that information into your formula that's found on your formula chart. In problem number 6, we're using the law of cosines to solve for angle A. We're trying to find angle A, and all we're given are the 3 sides. So we're going to use our cosine formula. Cosine A equals b squared plus c squared minus a squared all over 2bc. Now this form of the formula is not on your math chart, so you want to copy this form down onto your formula chart from your notebook if you haven't already done that, because you will need this formula for this test. Okay, so now what we're going to do is go ahead and plug in our values, and we get 6 squared plus 14 squared minus 9 squared divided by 2 times 6 times 14. That equals 0.8988. And so some of you are quite shocked when you get a decimal like that, but you're supposed to get a decimal. Okay, decimal 0.8988. And so we're still looking for angle A. So we need to solve for A by doing the arc cosine or inverse cosine. And that's why we have a decimal here, because this is actually the ratio. So we're putting it in as a decimal. And then when we do, we get angle A. And angle A in this case in radians is 0.4537, another decimal. Well, this is a radian. If your calculator's in radian mode, then it's going to give you the answer in radians. If we want the answer in degrees, then we need to take the radian, multiply times 180 over pi, and that will give us the degrees. In this case, the degrees are 26, approximately. So A is approximately 26 degrees. Final answer. Okay, in the next problem, number 7, you express in terms of sine, cosine, or tangent of one angle. Basically, all we're going to do is we're going to rewrite this formula right here, which is on your math chart. You need to look on your math chart to see what it is. This is a sum or difference formula. This one happens to be a sum formula, and it's the sum formula for sine of 22 degrees plus 43 degrees. So all we're doing is rewriting this sum or difference formula as 1 degree. So here we have to add these together. 22 plus 43, we get the sine of 65 degrees. And that is all you have to do for problem number 7. Okay, for problem number 8, you're using a double angle formula. It says use the double angle formula to rewrite the following expression. Again, all we're doing is rewriting. We're not solving this time. So if this is a double angle formula, then 420 is 2 times some angle. I'm just going to call it angle A. So 2 times some angle A is what tangent of 420 degrees is. So what is angle A? That's what we need to know. What is angle A? Well, angle A is 210. So when we rewrite this in our formula, we're going to use the tangent formula, which is 2 times the tangent. And this time we're going to use our angle, which is 210 degrees, divided by 1 minus tangent squared of 210. And that is how you rewrite it, using the formula. Final answer. Okay, so for problem number 9, we have something that's just a tad more complicated. In this case, we want to express in terms of sine, cosine, or tangent of one angle. And if you look at this part right here, It almost looks like a double angle identity, except this is cosine squared theta minus 12. Well, that's not exactly what we're looking for. So what we need to do is we need to factor out the 12 first. So we're going to factor out a 12 from the 24, and we're going to factor out a 12 from the 12. So what we end up with is 12 on the outside of the parenthesis. We end up with 2 cosine squared theta minus 1. Well, 2 cosine squared theta minus 1 is one of our identities. It's one of our double angle identities. And it's the double angle identity for cosine of 2 theta. So I can rewrite 2 cosine squared theta minus 1 as as cosine of 2 theta. So I'm going to rewrite it as that, and that's it, my final answer. All right, problem 10. We are to find all the solutions to the equation on the interval 0 to 2 pi. Now this right here, this open parenthesis means we're not going to include 0 in our solution set. So, but we can include anything between there and 2 pi as our solutions. So the first thing we need to do is we need to look at our equation and see if we have anything that, hey, this right here is a double angle. So I can use my double angle identity to rewrite sine of 2x. And I'm going to rewrite sine of 2x to be 2 sine x cosine x. And that's a good thing, because now what I can do is I can factor out what I have in common in my equation. And what I have in common is this 2 sine x. So I can factor it out. 2 sine x. And what I have remaining is 1 plus cosine x. So I have 2 parts here that I need to solve for, just like with quadratics when we did quadratics and we had 2 factors that we needed to solve both sides for. So let's do sine first. So 2 sine x equals 0. So divide by 2, I get sine x equals 0. So now I want to look at my unit circle and say, okay, well, where is sine x equal to 0? Well, x, the angle where sine is equal to 0 is at angle pi and 2 pi. Okay, let's solve for the other one. 1 plus cosine x equals 0. Subtract 1 from both sides, I get cosine x equals negative 1. And now I want to ask myself, okay, where in my unit circle is cosine equal to negative 1? And that would be where x equals pi. And those are our solutions. Final answer. Okay, question 11. In question 11, we're going to use the half angle formula to evaluate the following expression. All right, so we have cosine of 165. If I want to rewrite, fix that. If I want to rewrite my cosine of 165 into a half angle, then I would need to do cosine of some angle divided by 2. That some angle, whatever it is going to give me 165. So what is that angle? Well, if I double 165, I get 330 degrees. So I know my angle is going to be 330 degrees. That's the angle I'm going to use in my formula. So I go to my formula chart and I see that the cosine formula is 1 plus the cosine of the angle divided by 2 plus or minus the square root. Okay, well, where on the unit circle is cosine 165 degrees? Where is that? Okay, well, if you look at a circle and you look at the degrees, you see that 165 is going to be somewhere in here in quadrant 2. And cosine in quadrant 2 is negative. So we know that we're going to be using our negative square root in our answer. So negative square root, and now we're going to use the cosine formula for the half angle formulas. And that is 1 plus the cosine of 330. So you have to look at your unit circle to see, well, what is the cosine of 330 degrees? And if you look on your unit circle, you'll see that it's root 3 over 2. And all of that is over 2. Now notice that my radical is over the entire expression. So don't cut your radical short. If you do, you're going to end up with the wrong answer, okay? So negative radical over the whole thing, 1 plus root 3 over 2 over 2. Now we have to go through the trouble of simplifying. So negative radical, and now I'm going to simplify this a little bit. I have to add the 1 with the root 3 over 2. So I'm going to change my 1 to root 2 over 2. So I have a common denominator plus root 3 over 2 over 2. Okay, so now I'm going to keep my negative sign. I'm going to keep my big radical. And I'm going to combine my numerator. 2 plus root 3 over 2. All of that over 2. Okay, so I'm still not done simplifying yet because I have a fraction divided by 2. So I need to take care of that. Well, I'm going to take this 2, I'm going to make it 2 over 1. I'm going to loop it around. I'm going to put it up here, and I'm going to multiply by 1/2. Okay? So 1 times 2 plus root 3. Keep my negative radical. So 1 times 2 plus root 3 is 2 plus root 3. Over, and then I have 2 times 2 is 4. Well, I'm not quite finished yet. I can still simplify the root 4 in the denominator. So I'm going to keep my radical on the top in the numerator. I have my 2 plus radical 2 in the numerator, or radical 3, I'm sorry, in the numerator. And all of that over 2. Now, this 2 down here is no longer under the radical because I took the square root of 4 right here. I took the square root of 4, and the square root of 4 is 2. So now I don't need my radical to extend all the way down here because I took the square root of 4. So it's not square rooted anymore. But it is up here, so I have to keep it. So I actually have a root inside of a root, and that's okay. And then I'm just going to put a box around that and say final answer. Okay, in problem 12, we're going to express in terms of sine, cosine, or tangent of one angle. Again, I'm using my formula chart. This is obviously a half angle formula, and it is the half angle formula for sine. So we will say alpha over 2. So if this is the half angle for sine and our angle is 210, then we could say sine of 210 over 2, which is sine of, and then 210 divided by 2 would be 105 degrees. Final answer. The last part of your test is going to be a writing prompt, so just be prepared for your writing prompt. It's going to be about question number 12. How did you determine which identity to use and which formula to use to find your answer? And that's it. Good luck, Longhorns. Okay, oops, wait a minute. In problem number 11, our final answer here should have been, remember, negative, because cosine of 165 degrees is in quadrant 2, and in quadrant 2, cosine is negative. So we need to keep that negative sign in front of our radical. And now we're finished. Good luck, Longhorns.